Okay, good morning. So let us continue our lesson. So we learned a little bit about rational expressions. We learned to simplify the rational expression. If I give you one single rational expression and I ask you to simplify that, you know how to do it, yes? But now we want to go and do something with rational expressions, even though when you want to learn arithmetic, you start learning addition and subtraction first, and then you will learn multiplication and division. But because multiplication and division in this case is simpler, we want to teach this one first, and then we continue for the last operation, and that's addition and subtraction. Okay, so the point here, let us discuss about multiplication first. Actually, you really don't need a teacher for that, because if I have a fraction, a over b, and I ask you to multiply it by c over d, you know what to do. So what is the rule if I want to multiply these two? So you have to multiply the numerators and write it as the numerator of a fraction, and you do the same thing here, b times d. Okay, so this is not something that you need a teacher for, you already know about that. But extremely important in this case is to, if you are used to multiplication and then simplification, I really want you to learn to do it this opposite one. For numbers, because you usually use your calculators, you really don't care about that so much. But I really want you to care about these things that I want to tell you right now, because otherwise, if you face a hard problem, it would be very hard for you if you want to simplify them. So here, first of all, what type of simplifications are allowed? You see, if I multiply this by that, then I get a fraction in this form. Yes, this is something that you already know. And then if I ask you, is this a product? You would say yes. Is this a product? Yes. So A and C are factors. B and D are also factors. So if I can simplify A with B somehow, I can do it. This means that before starting, I can simplify this with that. Can I simplify in this form A with D? So if I give you this, for example, if I give you 4 times 5, and I would write 7 times 16. If I ask you to simplify that, of course, you might multiply and write 20, and then you have to multiply this. So what is that? It's 102, and then you start simplifying. But this is not efficient at all. So what I want you to do is to be able to simplify it. So can I simplify this 4 with this 16?
Yes.
Yes, because 4 is a factor, 16 is also a factor. So you see that. Can I simplify A with B if possible? The answer is yes. Can I simplify A with D if possible? The answer is yes. So let us write this. You can simplify these two. So you can also simplify these two, yes? Okay, can I simplify C with D if possible?
Yes.
Yes, so this means that this one is also possible. Can I simplify C with B? The answer is yes. Okay, I really want you to learn simplify first and then continue. Technically, yes, you are right. There is no difference. You can multiply and then simplify. But it is not efficient at all. So you remember, when I wanted to do this, I did it very quickly in my head 20, then I thought a little bit for doing that. But assume that I just simplify 4 with this 16, then it becomes 1, and then it becomes 4. I really don't need to think at all. 1 times 5 is 5, 7 times 4 is 28. So you see the second one is more efficient. So that's what I'm always telling you. Get used to this one, please. Because here we are not dealing with numbers, we are dealing with algebraic expressions. If you get used to multiplying and then simplify, that could be a problem for you, okay? Because it might be very hard to do that. So try to develop this habit so that you can simplify this one. Always, before starting doing this multiplication, think, can I simplify vertically? Vertically? Can I simplify in this cross manner? If you can simplify, do all the simplifications and then start multiplying. Yes? Okay, now, for example, let me give you an example. Okay, very simple examples first. For example, y divided by x squared minus 4, I want to multiply it by x plus 2 over y squared. X plus 2 over y squared. Yes? Okay. The first thing, because you want to ask yourself, can I simplify this? This is the previous lesson. Simplification vertically is the previous lesson. Can I simplify this? Can I simplify this? If you want to answer this question, do you remember we have to factorize each one of them? We have to factorize each one of them here. So let me change my color. So the one that I write in blue would be my solution. So if I want to solve this, I have a rational expression. I have another one, I want to multiply them. So what I do, I try to factorize everything possible. Y cannot be factorized anymore, but x squared minus 4 is a famous pattern, yes. It's x minus 2, x plus 2. And then dot. Can I factorize x plus 2? No, this is just first degree polynomial. And y squared is already in factorized form. Y squared is y times y. Now, so this is part of the solution. This is why I changed my color. So can I simplify vertically here?
No.
No. Can I simplify vertically here?
No.
No. Can I simplify in this cross manner?
Yes.
Yes. So you see, what you do, you divide this by y, becomes 1 times. You divide this by y, what is left? If I divide this by y?
Y.
Yeah, because I have 2 factors, one of them is gone. Can I simplify in this cross manner way?
Yes.
Yes, because x plus 2 is a factor, x plus 2 is a factor. I divide this by x plus 2, it becomes 1 times. And I divide this by x plus 2, it becomes 1 times. Yes? And then what you do, after simplification, it is not compulsory, but let me write, not to get confused. This part is not compulsory. Let me write what is left for me. 1 is left from here. X minus 2 is the only one left, so I would write it x minus 2, and I don't need brackets. And then dot. In the numerator I have 1. In the denominator I have y. And then I simplify. I told you that you don't need to write this. You can just do it in your head. So 1 times 1 is 1. X minus 2 times y. Even though this is completely acceptable, but I prefer that when I know that this is not possible to simplify it anymore, I myself prefer to remove the pair of brackets, but that's not compulsory. So what you do, I would write y and I multiply this y inside. So it becomes what? xy minus 2y. Either you can choose to stop here or you can choose to stop there. Yes? And this is optional. Optional, it means that optional for writing, not optional for thinking. Yes? Yeah. That's also, let me write this optional. Okay, is that clear? Clear. So that is the problem. So it's not actually something new. Most of the thing which is problematic for you is factorization. So if you are not very good in factorizing polynomials, then you will face trouble here. Otherwise, if you know what to do, it's very simple. Okay, so let me ask you to do this one for me. X squared minus x divided by x plus 5 multiplied by x squared plus 5x plus 4, x squared minus x to the 4 minus x squared. Okay, let me solve this one myself because I want to also explain something more. Okay, so if I want to do that, I have a rational expression, another rational expression, I am supposed to multiply them. So what I have to do, I have to factorize whatever I see here. So for factoring this, I hope that you know what to do. What I'm supposed to do?
X.
Take x out. So this becomes x minus 1. In the denominator, I have a first degree polynomial, so that's the only thing that I can do. For the denominator, it's very clear. What's the denominator? What should I do?
X squaring.
I should take x squared out. That's not a squaring yet.
Oh.
I should x squared out. It becomes x squared minus 1. And for the numerator, I don't know how many of you remember the previous lesson. So we can solve it. Let me solve it with the method that I described you last time, but I want to tell you something easier this time. And if you use it, that's completely acceptable for me and even better, okay? So I told you, do you remember how should we factorize the quadratic polynomial? So let me write the formula here. So what was the formula? The general case is if I have this, I can write it as x minus a times x minus x1 times x minus x2. And if I ask you what are x1 and x2, you would say that these are the roots or zeros of this. So if I want to factorize this using this method, which works every time, I would say that I will go and solve this equation myself. So by the way, let me write this one with blue as well, because this is also part of the solution. So what you do, you put this one equals to 0, and then you try to solve that. So delta is this 1 to power 2, minus 4 times 1 times this is 16, so it becomes 9. And then you write x is minus b plus or minus square root of 9, which is 3, divided by 2 times a, which is 2. So I will get two roots. One root is minus 5 plus 3 divided by 2 is minus 1. And the other one is minus 4, yes? But now, what can I write? I can write x squared plus 5x plus 4 is equal to, so I open two pairs of brackets, I put one x here and the other x there. Okay, x minus x1, x minus x2. What happens for this a? In this particular problem, what is the value of a? Is 1. So this is also 1, so we don't write it down at all, yes? So this is why I would write x minus x1, which becomes x minus minus 1, which becomes plus 1. And x minus the second root, which is x minus minus 4, becomes x plus 4. Yes? So that is the factorization of that quadratic polynomial. And then I can just transfer it here, so it becomes x plus 1 times x plus 4. Okay? But for these cases in which this number is 1, you can guess the answer, and it is much faster, especially for these small numbers. Yes? So you should ask yourself, so if I want to factorize this, I will never do it in that form. What I do, I would say that if I want to factorize this, I open two pairs of brackets, and I put one x here and the other x there, if this number is 1. Yes? Then I ask myself, can I guess two numbers whose sum is this number and whose product is this number? Of course, I cannot expect you to guess these numbers if these numbers are big. But if the numbers are not big, which they are not usually big in the exam questions or in the book problems, you can guess. Can you guess two numbers so that the sum of those two numbers is positive 5? You need to consider the sign as well. And when you multiply them, it turns out to be 4. Extremely clear. So I would prefer starting from 4. 4 can be written as 1 times 4 and can be written as 2 times 2. Okay, 1 times 4. If I add them, what happens? It becomes 5. So the pair that I was looking for is 1 and 4. So I would write 1, positive 1 here, positive 4 there. You see, immediately you can write it down. Don't spend so much time to solve these simple questions. Of course, if these numbers are big, and if this coefficient is not 1, of course I can modify this method to solve if this coefficient is not 1, but that's also a little bit lengthy. Okay, unless you can do guesswork. And by the way, here, if you can do guesswork, that's okay. You can just write the factorized 4. Yes? If I give you this, and you write this in the exam without an explanation, that's okay with me. So, if the answer is correct. If the answer is wrong, that's your problem. Yes?
This is a very efficient method. I used it in Math 2C, but you never mentioned it like the last one.
I am following the books actually, yes. So x plus 1, x plus 4 is here. So what I do, I want you to, whenever you see this, especially when you have this coefficient equal to 1, remember, consider this number with its sign to be s, the sum, this number with its sign to be p, the product. And then if these numbers are not that big, you immediately can find them. Yes?
So why can't you use it if A isn't 1?
No, if this A is not 1, then it becomes problematic. Because what you want to write, if you write x and x here, and if you multiply them, this becomes x squared with some coefficient which is not here. So I don't know, you can test it, for example. If I have 2x squared plus 3x minus 5, you can also do some guesswork. But if I write 1x here and 1x there, definitely this is wrong. Yes? Because if I multiply x by x, it gives me x squared, but I want to have 2x squared. As soon as I put the 2 here, then I will have problems here. I'm not saying this is not possible to do something similar here, but most of the problems that you are facing, you have this equal to 1, and then you can use this method. By the way, if this is not equal to 1, don't confuse this with PQ formula. If I ask you to factorize that, you are not allowed to divide everything by 2. Because I know some people get confused. They divide it by 2. Can I divide it by 2?
When what?
Because in PQ formula, if I want you to use PQ formula to solve this equation,
yeah,
and if this is not equal to 1, you have learned to divide by 2.
Yes.
Now I am telling you that, okay, I ask you to factorize this. Can you divide this by 2 and factorize that one instead?
No.
Yes?
No.
The answer is no, because this is not equality. In PQ formula, you have something equals to 0. You divide both sides by 2. This will work. But here I have one expression. If I divide by 2, I have to multiply by 2 as well. But then the question becomes a little bit harder. Can you guess 2 fractions whose sum is this and the product is this?
No.
It is harder to guess, but if you can guess, you can find that. Yes. So that's what I'm saying, that this method is especially very efficient if this is equal to 1. Yes. I will tell you more examples, hopefully, so that you can improve your guessing skills. But what I'm telling you that here, this is not based on guess. This is a structured way of doing that. Even if the numbers are so complicated, still I can do this systematically. But I cannot do the guesswork systematically. Guesswork is just guesswork. Yes? Okay, anyway. But can I continue a little bit more? Yes, because you see that this now reveals a conjugate pattern, so I can factorize that even more. Yes. So I would say that let us clean that. What is x squared minus 1? It can be factorized using conjugate rule. Yes. So let me clean this one and write x minus 1, x plus 1. Okay. I really want you not to start multiplying. Think about first, only about this. Can something be simplified vertically here?
No.
No. Can something be simplified vertically here?
Yes.
Yes. So do it. So this one and that one are gone. One is left, one is left. Okay. This is from vertical point of view. From this cross manner point of view, can I simplify something on top here with the bottom here? Yes. What are they? This one and that one. Even more, yes? This one. And how many x's are left? 1 x. But can I simplify in this cross manner way? No. So that's the only thing. I would recommend you try to not write it again, yes? So what I do, I will start multiplying everything which is left in the numerator. 1, 1, 1, and that expression. So this is simply x plus 4. And I will multiply this, by that. So it becomes what? And then of course, I hope that by now you know that you're not allowed to simplify these things. So if there is nothing simplified that I can simplify, I prefer to multiply. But that's optional, as I told you. So, and this is the simplified version, and I hope that you agree with me, working with this is much harder than working with that, yes? Of course, you need to remember, this equality is always true except for those values that make the denominator equal to 0, yes? At least one denominator becomes 0, then this will not be valid. Any questions? Okay. Now let us go to division. Then after everything is finished, we come back and solve a little bit harder problems, okay? So for division, we also have the same division of fractions. If I have a fraction a over b, and I am supposed to divide this by another fraction c over d, so you know the rule. What the rule is, yes, you write this a over b, you change it to the product, and you switch these, yes?
Yeah.
And then of course you reduce the division problem to a product problem, and then you multiply the numerators, and then you multiply the denominators, yes? But now let us look back here. Can I simplify a with b?
No.
Here.
Yes.
Yes, if possible, yes, because these are factors, yes?
Okay.
So this means that I can simplify this vertically. Can I simplify c with d?
Yeah.
Yes, so it means that vertically is still possible. But here, I can also simplify a with c, so it means that I can simplify horizontally. I can also simplify these two horizontally. But this is not my preference. Whenever I have division, immediately I change it to the product and solve the problem as product instead of learning a new rule, yes? So don't do this, even if you can do it. But usually, this is not a symbol we are using. So we write, instead of a over b, we write a over b. Instead of this one, you usually have another fraction line. And then you have c over d. Okay? And then what is the answer at the end? The answer at the end is a times d. So this is the way that I have learned. So you multiply these two that are far away from each other, and then put the answer in the numerator. And then you multiply these two numbers. You see b is supposed to be multiplied by c. So then I will put this one in the denominator. And then again, I can simplify a with b. So let me change my color. So if you want to simplify, so let me write a product here. So you multiply them here. But then if you want to simplify, you can simplify in this vertical way. And then you can simplify the numerator by the numerator. I don't know, it's a little bit confusing. And denominator with the denominator. So for example, if I want to simplify 5 over 12 over 35, 36, if I want to do this calculation, the first thing that I think is that, is it possible to simplify these two? No. Is it possible to simplify these two? No. But is it possible to simplify the numerator and the numerator? Yes. So this I divide by 1, I divide by 5. Can I simplify the denominators? Yes. This is 1 times and this is 6 times. So what is left for me is 1 over 1.
Hold up there.
It's 3.
It's 3, yes. Thank you. So what is left is 7 over 3. But then I multiply this by that, it becomes 3. I multiply this by that, it becomes 7. So the answer to this is 7. Okay? It's 3 over 7. So I want you to learn this, because usually we do not use this symbol. We usually use another fraction line. And I will always use this method. I will take this one and multiply it by that one, which are far away from each other, and put it in the numerator. And then when I divide these two, I also multiply them and put it in the denominator. So by the way, if I ask you to do it quickly, what is the answer? So what is the answer to this?
AC over B?
No.
Okay.
A over BC. Be careful. Why? Because another way of looking at C is C over 1. And then this goes here, 1 times A, and then B times C. So if you divide, for example, if I give you 5 over 7, and I ask you to divide this by 10, you immediately write it 5 over 70, because you multiply that 10 by the denominator of the first one. So these are the elementary things, but here of course we are interested for algebraic expressions. But that's the idea. The same idea will work. Yes? Any questions? Okay, so let me try to give you some examples. Okay, so let me write this. Let me write a very, very simple one first. 16 x squared y divided by 24 xy cubed divided by 9xy divided by 8x squared y squared. It's a very, very simple one, of course. So what I'm supposed to do, I would write the first fraction as it is. And then I change this to multiplication and I write the reciprocal, which is 8x squared y squared divided by 9xy. And then I can completely forget about division and think about multiplication as I learned before. And of course, I will know what to do. First, I will ask myself, is it possible to simplify vertically? Yes, the answer is yes. For example, this number divided by 8 becomes 2 times and this 3 times, yes? And this x is simplified with this, 1x is left, and this y and this y3 are gone, y squared is left. This is the vertically simplification of this one. Can I vertically simplify here? Yes. 8 with 9 I cannot simplify, but this x with this is gone, 1x is left, this y, and that y is gone, y is left. And by the way, let me write also 1 here, 1 there, when I simplify these things. This is also 1 and 1. But it is still not finished. I need to consider the cross-manner simplification. 2x1, 9, 1, 1. So no simplification is possible in this way. But what about this way? 8 and 3 cannot be simplified. I have x. Okay, here I have y squared. I have another y left there, yes? So I simplify this by y. It becomes 1 times. I simplify this by y. It becomes y. Now nothing can be simplified more. Now I will start multiplying them. So I will start multiplying 2 by x by 1 by x by 1. The answer is 2x squared. And I will start multiplying 3 by 1 by y by 1 by 9 by
Wait, you missed the 8.
What?
8. 2 times 8.
Oh, okay, thank you very much. So it becomes 16. Thank you very much.
Yeah.
16, yes.
Exactly.
And then here we have 3 times 1 times 9, which is 27. And then I have 1 times y, that's just y. That's the answer. Okay. Now I want to write something and I want to wait for you, okay? I want to wait for you to solve this for me. So 3a squared, it's very simple. 12 plus 12 divided by 3a squared minus 15a divided by a to the 4 minus 16 divided by a to the 2 minus 3a minus 10. Okay, I will pause this recording and give you 5 minutes at least to solve that problem, okay? But of course, I think you can do it even faster. I will write one more, so if you finish, you don't waste your time, go to the next one. If you finish the first one, do the second one. You need to understand what is the combination of a product and division in one problem. Okay, so let us at least see what is the first one. If you are sure about that you have done the first one right, you don't need to listen to me, you can just continue doing that. But for the people who have some troubles still with the first one, just listen to me, okay? So if I want to solve that one, I know that this is a division, I have to change it into the product, and then I have to reverse these two. But I know that at the end I have to start factorizing things, yes? So why not we can just do it from now. Can I do something in the numerator of the first one? Yeah. Yes, I can factor the 3 out, so it becomes a squared plus 4. And can I do something for the denominator? I can factor a what? A 3a out, then what is left is a minus 5, yes? And I change that to multiplication. And then what I have to do, I need to write this in the numerator and write this in the denominator. Let us consider that one. If I ask you, can you factorize a to the 4 minus 16? What is the answer? Can you factorize it? A to the 4 minus 16.
Yes.
Yes, what's the pattern?
Conjugate.
It's a conjugate pattern. So, but it is in the numerator, I will write it in the denominator because I have already changed this to a product. So that becomes a to the 2 minus 4, a to the 2 plus 4. Is that understandable?
And then you can...
Yes?
Okay.
But can I factorize this even more?
Yes.
This one no, but this is again a conjugate pattern. So instead of a squared minus 4, what can I write? A minus 2, a plus 2. I cannot factorize this more. But this is the first time that I want to do it from scratch. Of course, you can use the formula, ABC formula, to find the roots. But can you tell me how can I factorize that? Of course, I hope that you understand here, a is playing the role of x in this expression, yes? So what I do, I open two pairs of brackets. I would write a here and a here. And I ask myself, I want two numbers so that the sum is negative 3 and the product is negative 5. And I think it's not hard to understand. What are those numbers?
Negative 5.
Negative 5 and? I want two numbers.
Negative
Product
5.
should be negative, tell you everything.
The product is negative and the sum is also negative. So it means the negative one is bigger.
2.
Minus 5 and 2. Yes? Because if I have minus 5 and I multiply it by 2, it becomes minus 10. That's okay. I want minus 10. If I have minus 1 plus 2, it becomes minus 3, and that's exactly it. So I found my pair. And one of them is minus 5, the other one is 2. The product is minus 10, the sum is minus 3. You write one of them here. So then I would write minus 2 minus minus 5, which is positive 5. Oh, sorry, I made a mistake. I have to write 2 here and minus 5 there. So whatever you find, you just transfer it here. The numbers that I was looking for was minus 5 and 2. So I write 2 and minus 5. If you want, you can double check. A times a is a squared. A times minus 5a is minus 5a. 2 times a is plus 2a. And then 2 times minus 5 is minus 10. And then you see this becomes minus 3a and this is minus 10. So minus 3a minus 10 is exactly what I have. So what I have written here is completely correct. Don't get confused. In this method, you shouldn't change the sign. You have to write the same number.
Yeah.
Okay, now everything is ready to simplify this expression. So can I simplify something vertically here? Yes. This 3 and that 3 are gone. Nothing more. Here, can I simplify something vertically? Yes. This one and that one are gone. Now, can I simplify in this way? Yes. This one and that one are gone. Can I simplify something in this way? Again, yes. this one and that one are gone. So in the numerator only 1 is left multiplied 4 times, so it becomes 1. What is left in the denominator? 1a is left here and a minus 2 here. This is good to stop, but I prefer to multiply when nothing is simplified anymore. So this is the simplified version of that product, yes? And actually it's a huge simplification, yes? Instead of working with this ugly expression, we just work with this nicer one. But before going to the next problem, I intentionally, it was a good problem in that book, so that's a mixture of product and division. When you have more than one operation, you always think about prioritizing the operations. Okay, so let us think a little bit about this. If I give you 2, just number 2, and I multiply it by 3, and then without any pairs of brackets divided by 5, for example. If I ask you what that number is it ambiguous or not? It might be ambiguous because how many operations are involved? 2 operations. I can interpret this in this way. It means that I am prioritizing the multiplication over division. Or it could be something like that. Yes? It means that I am prioritizing the division over multiplication. If the results are different, then this is ill-designed. So it means that if this one and this one are different, they have to mention it in the problem itself, which one they mean. Unless we have a good reason, there is no difference between this one and that one. If there is no difference between this one and that one, we don't write the pair of brackets because it doesn't matter, yes? Okay, so let us check. If I want you to do this, you multiply 2 by 3, it becomes 6, and you divide 6 by 5. I don't know what that is. It is 1.2. And if I do this one here, what should I do? I need to write 2 times. I have to divide 3 by 5 first, which is 0.6, and then multiply it by 2. What's the result?
Same.
The same number. So remember, if you want to show it by the way, if I have a dot b divided by c, it means a dot b divided by c means ab over c. A dot b divided by c means a dot b over c. But instead of a, I can write a over 1. It becomes ab over c. And they are always equal. So this is why in the book you do not see any pair of brackets to prioritize these operations. It doesn't matter which one you want to do first. Yes? So you can just without any pair of brackets solve that problem. Okay, so that's what we want to do. But let us do them in parallel because it would be very lengthy. If you want to do it step by step, it would be very slow. We know what is the goal. I want to factorize whatever I can, yes? So in the first one, what can I factor out? In the first numerator,
X.
x, only x. So what is left is 2x plus 3.
Yep.
And then in the denominator, I can factor a 2 out and
2x squared.
and
X
yes,
squared.
2x squared, yes.
Yeah.
And then it becomes x minus 5. Yes? And then I go to the product. Let us do the denominator first, it's easier. What can I factor out? 3 and x, yes? So what is left for me is x minus 9. Okay, in the numerator, this new technique, this is fortunately 1, so I can use this trick that we just learned. I want 2 numbers whose sum is negative 8 and the product is 15. Before doing that, open 2 pairs of brackets, put x here and x there, and whatever you find, just transfer them here. Do not change the signs in this technique.
Minus 3 and minus 5.
Minus 3 and minus 5, yes? It's that simple. So you just put minus 3 and minus 5 here, yes? And then we go to the next one, but because that's a division, we need to know that I have to change it to the product, and then I'm supposed to write this in the denominator. But before writing this, I can see that I can factor something out. What is that thing?
7.
7 and then it is 2x plus 3, and in the numerator I will use the same trick. I ask myself, I need a pair of numbers so that the sum becomes negative 6 and the product negative 27. So can you guess those numbers? If you can guess, it is much faster.
3. 9 and minus 3.
Minus 9 plus 3, not the other way around. Because the sum is supposed to be negative. Yes? Now everything is in order. Can I simplify something vertically here? Yes. So this one and that one are gone. Vertically here, no. Vertically here, no. But now, can I simplify something in cross manner? By the way, in cross manner, can I simplify this one with something here? No.
No.
But with something here, yes. So you do that. So you divide this by that, it becomes 1, and this one is also gone. Okay, this one and that one can be simplified. Yes? Okay, let us not get confused. Everything is in order now. So what's left here? So x minus 3, okay, x minus 9 here. Oops.
Yeah, you can do that.
X minus 9
And the other one.
and the other one here.
Yeah.
Yes. But what is more? Apparently nothing more.
Conjugate.
Do you agree with me?
Yes.
Okay, so if I start multiplying them, 1 times 1 times this one times this one. So there are only 2 things left. I have to multiply them. And then what is left in the denominator? I have 1, 2 here,
2x.
and 1x. Multiplied here, 6. Multiplied here is 42. I have 1x here and 1x there, which is x squared. Of course this is correct, but when nothing can be simplified, I prefer to get rid of a pair of brackets. And then I can use again the conjugate pattern. So the answer is x squared minus 9 divided by 42x squared. So this is the simplified version of that expression. And this is actually, I would call it an art. Of course, this is a simple problem, but you really need to improve your skills in simplifying algebraic expressions, yes? So instead of working with that horrible expression, you just throw it away and work with this one, yes? Okay, before doing that, so we have a little bit of time, so let me just pause recording, and I want to see how GeoGebra is capable of simplifying this. I would say that this is fairly complicated, but let us see how we can use GeoGebra to simplify that expression. You have questions?
Yes, what kind of level question would this be on the test?
I haven't seen the questions in the book, but might be, this is an A-level question.
Okay. Didn't it say like if it has 2 stars or something on the book, or was this in the book? Or
No, no, it was in an American book.
Oh, in an American.
And this is actually a very, very nice lecture notes. It's part of a book, and I think according to copyright, we can actually have a little bit of the book distributed. So I will try to put this one on the Google Classroom, so that it's a very nice, user-friendly way of teaching this. A lot of examples.
Well, like how's the Persian book or the
I
question?
will record. Yes. So we go here. Of course, if you want to do these kinds of calculations, you know that you should go to CAS view.
Yes.
Okay. And then I would prefer to get rid of this algebraic view because we don't need it. So let me take this graphics off. Okay, we have here. And what do you think we should start with? we need a command, yes? So I would say probably simplify is a good way to start, yes? Okay, there is a simplify command here. So we use this, and then we have to start typing it in. I want to type the second one, which is harder, but what I'm saying, this is my impression. If I write 2x, first of all, is the Swedish, yes, this is English. 2 to the power of 2,
Yes.
and then I write plus 3x.
Yes.
If I just do division, definitely GeoGebra will only divide the second term. Yes? You see, if I do the division, this fraction line only goes below 3x.
Yeah.
But so you need to see this ahead of time a little bit. I know that the whole thing is going to be divided by something else, so I have to put a pair of brackets, even though the pair of brackets is absent in the original question. Yes. So I go back. Let me clean this. So if I want to do that, I need to anticipate that I need the whole thing, and then I would write 2x to the power of 2, and then go down plus 3x.
Yeah.
And then press this bottom division. No, okay, so no, because I have to go out and then press this.
Exactly.
And then automatically that pair of brackets is actually removed, yes?
Yeah.
And then I will go to the same story, so let me just do it quickly. This one minus 10x squared. For the denominator, of course, I don't need any pair of brackets. Then I go here, outside here, I multiply it by another fraction, but I know that by experience I need a pair of brackets, so x to the power of 2. Can you read it for me, please?
Minus 8x.
Yes?
No, it's
Okay, minus 8x.
plus 15
8x plus 15.
over,
I have to go out again,
yeah,
and then over. So I think I can use yes.
3x squared
3x to the power of 2
minus 27x.
minus 27x. And then I have to go out. And then I know that this will not work exactly like this, but this doesn't mean GeoGebra is wrong. Yes, this is correct.
It's still right.
Because GeoGebra is putting the whole expression below that one. And it doesn't matter, because I told you the priority, it doesn't matter here. So that is correct. You cannot do something else.
Yeah.
And then I go to the denominator, I have to do 14x. So I have to open a pair of brackets again, and then plus 21. Continue reading, please.
X squared minus...
And then division, x squared
Minus 6x.
That's disgusting.
minus...
No.
6x.
Yeah, x squared minus 6x.
Minus 27.
Wait, it's wrong again.
Oh,
You're writing it, yeah.
yeah. So again, yes,
Minus 6x minus 27.
minus 27. Yes? I don't know. Hopefully GeoGebra, because simplification is not completely clear for the computer.
Okay.
What do you mean simplified? Do you think, is it simplified version? Is that simplified version? There should be some small differences. Let us see how it goes. No. It's x squared
Yeah.
minus 9 divided by 4.
That's exactly right.
So it actually knows what to do. Yes? So I think that's also good. So you know that the command is simplified. Yes? And it actually worked. So at least it shows that we haven't done something wrong. Yes?
Yeah.
Any questions here? Okay. Now let me close this. Okay, so let me start the last topic here. If we cannot finalize it, then definitely we can finalize it next session, but then we go to the next topic, the last part of this chapter after this. So let me write addition and subtraction. This is much more technical. This is why we reverse the order. Usually I told you that you learn addition and subtraction first in primary school, and then you will learn about multiplication and division. The reason we did it the other way around is because multiplication and division is simpler here in this case. But let me remind you what we do. If I ask you, if I give you a fraction 2 over 3 and I ask you to add it to 1 over 3, so what can you do? Because you see the denominators are exactly the same, so what you do, you just write the same denominator and then you add the numerators. And then of course you don't stop here, you continue, it becomes 3 and then you have 3. And you don't even stop here. If you can simplify, you simplify it and it becomes in this case equal to 1. Yes? What happens if the denominators are not the same? So you have to make them the same by rescaling them. For example, if I give you 5 over 2 plus 7 over 3, if I ask you to add them, you see that the numbers are not the same, so you have to rescale them into a common denominator. Yes? So what should I do? I want to make the common denominator. By the way, the common denominator is what is technically called least common multiple. Yes?
Yes.
And I really, because if I only care about common multiple, the first choice comes to mind is the product. For example, if I ask you, can you give me a common multiple between 15 and 20? What is the common multiple? Don't get confused. I am not asking about the common divisor. or a common factor?
5.
Okay? If I ask you, that is what I'm saying. Don't get confused. I'm not asking about the factor. If I ask you, can you give me a common factor?
300.
Then this is what a common factor is 5.
Yeah.
Yes? A common factor or a common factor or a common divisor is 5.
Yes.
When you say 5, it means these numbers are supposed to be divisible by the number that you propose. But common multiple is exactly the other way around. You need to give me a number so that they are divisible by these
This
numbers.
is 300.
300 is the first thing that comes to mind,
Yeah.
but we have better. So if you say 300,
60.
this is not wrong,
It's
because
60.
300 divided by 15 is possible, 300 by this. But as you said, 60 is much better.
Yeah.
And this is extremely important for me, that I want you to learn this. Even though you can solve this problem that I want to mention, for example, let me write this, 1 over 15 plus 3 over 20. If I ask you to solve that, of course you can use 300, but it is much easier for us to work with 60. Here might be, it looks like a luxury or something, but when it comes to algebraic expressions, it is really, really important, because if you don't want to care about this part to make the least common multiple, just write a common multiple, then you face a very big problem. It becomes really, really hard to solve sometimes. Okay, so what I'm saying, let me just do this here. If I insist to solve this with 300, it is possible. So what should I do? I will write 300 here. I will write 300 here. I divide 300 in my head by 15. What is that done? It's 20 times. I multiply 20 here. So if I ask you what is 20 over 300, you would say it's exactly equal to 1 over 15. And I divide 300 by 20. It is how much? 15 times. I multiply this 15 by here, it becomes 45. And then I add them. It becomes 20 plus 45 is 65. But you shouldn't stop here, because this now can be simplified. For example, by 5, it becomes how much? 13. This becomes 60. And that would be your final answer. Yes? But now this is, I don't like it, correct, but not efficient. You see, we didn't spend that much time, even though it was not efficient, it was manageable. Yes? But in algebraic expressions, if you want to follow this habit, this you will face a lot of troubles. Instead, what would be the efficient way to do that? I would say 1 over 15 plus 3 over 20. I will write 60 and 60. 60 is the least multiple, common multiple. 60 divided by 15 4 times. 4 times this is 4. 60 divided by 23 times. 3 multiplied here is 9. And if you add them, 4 and 9 is 13, and that's 16. And then you get the right answer. Yes? So you see that it was not that different here and there, because the numbers are not so big. So this, I would say, correct and efficient. Yes? So I want you to understand this point. So yeah, change your habit, because I know most of you, when you want to do this problem, you just simply multiply. Yes? So by the way, how we can find 60? If you multiply, you get 300. But if you want to find 60 systematically, assume that these numbers are so big that you cannot guess the most efficient number. So you have to factorize this, which is to prime numbers. It is 3 times 5. And then you have to factorize 20 as well, which is 4 times 5, but 4 itself is 2 to the power of 2 times 5. Yes? So you have to factorize this, you have to factorize that. And if you want to find the least common multiple of 15 and 20, you need to write a number which is divisible by this and divisible by that. To be divisible by this, you need a factor of 3 and a factor of 5. To be divisible by this, you need a factor of 2, another factor of 2, another factor of 5. But you have already written factor of 5. You don't need to repeat it. So what you need to repeat, what you need to add is 2 to the power of 2.
And it has to be 2, not just single 2.
No,
Yes.
single 2 will not work,
Yeah.
because single 2 has not enough to itself to
Okay.
simplify. So then you write this. So what is happening, instead of repeating 5 2 times, I just repeat 5 1 times, because that 1 5 will work here and there. I don't need to repeat it. So if I multiply these numbers, 3 times 5 is 15, times 4 is 60. And this is what we got in our head. Yes? But that's exactly the idea we want to transfer to the algebraic expressions. If I have algebraic expressions, I want to add them. So what I have to do, I have to factorize them and find the common factors with the highest power. Yes? So you see, if I ask you what are the factors you see in front of you, you see a factor of 2, you see a factor of 3, you see a factor of 5. But you choose the highest power. For 3, I have the highest power equals to 1. So I choose 1. For 5, here is 1. Here is also 1. So again, I choose 1. But for 2, what is the highest power? Is 2. So I write 2. So that is the way that you can find the least common multiple. Okay, factorize them. After factorizing is finished, write all possible factors that you can see and choose the highest power that appears somewhere in your list. And then multiply it. Yes.
Okay, if you have two like 2 to the power of 2 and 2, are you just going to have to pick the one with the highest power?
Yes, exactly. So is that clear? Okay, now let us make it more fun by going to algebraic expressions. Let me start with very simple examples first. I think there are some simple examples here. And for the subtraction, by the way, it's the same thing. Yes. So let me follow this American teacher here. So I think these examples are good and simple. So if I want to simplify this, let me just start with very simple examples first. X plus 2 divided by 4 plus 3x plus 1 divided by 3. Okay, I hope that you agree with me. By the way, let me ask you something. Can I simplify vertically if possible?
Yes.
Yes, because always you can simplify vertically when you face a fraction. Okay, so, but can I simplify something vertically here?
No.
No. Can I simplify something vertically here? No. So this means that I have to start solving the problem. So I need to find the common denominator here. So what's the common denominator?
12.
It's 12. It is coincidentally the product.
Yes.
Yes, it's the product. So, but I prefer, I don't know, I think you can manage it. What I want to do, it's very hard for us to write so many things. So immediately you find the common denominator, just write it, and write a longer fraction line. And then I want to skip the middle one, because it's just boring to write everything in detail. So you divide 12 by 4 in your head. What's the answer? 3. And then you multiply 3 by its own numerator. But this is the wrong way of writing, yes? If you write it in that way, that's wrong. What should I write? What should I write?
You should put it in parentheses.
Pair of brackets,
brackets.
yes? And then I have addition, so I put a plus sign here. And I repeat the process. 12 divided by 3 is how much? 4. I multiply 4 by the numerator. So 4 times 3x plus 1. Yes? And that's it. This is the only new part. The rest of it is to simplify the numerator, as in Math 2C. So what you do, you multiply 3 here, 3x plus 6. You multiply 4 there, 12x plus 4. And then you divide it by 12, and then you continue. So 3x plus 12x is 15x. And then 6 plus 4 is 10. And then you have 12. Okay, but one thing is that here I don't continue because I look ahead, a little bit ahead of myself, and I realize this is not possible to simplify. But in principle, you need to check because this can be factorized. You see, this can always happen. It sometimes happens that after adding two expressions, then you get a common factor out. So you see here, I can factor 5 out, but in this problem it is useless. Because even if I factor it out, this cannot be simplified anymore. Yes, but you have to be careful about. Yes, if it is possible to factorize, you have to think about factorized version. Might be, for example, I don't know, if I could factor a 2 out instead of 5, then I can simplify that 2 with 12, and you have to do it. If you don't do it, that's not complete. Yes? So I will come here, and then I will stop. Is that clear? Yes?
But in this question, which one do you think is it like enough with 15x plus?
Yes, yes. Okay. So let me give you another one with numbers, and then we can go to a little bit harder ones. And then I think this would be the last example that I want to solve now. Yes. We continue this lesson next time as well. So x plus 3 divided by 10 plus 2x plus 1 divided by 15 minus x minus 2 divided by 18. Yes. So we want to simplify this expression. I don't know, can you do it in your head between 10, 15 and 18? Can you find the least common multiple?
No.
Okay, if no, but the solution is simple. So you need to be patient and factorize 10. It becomes 2 times 5, yes? You remember, by the way, factorization method. I told you, you draw a vertical line, you put prime numbers here, so that this number is divisible by that prime number. It becomes 5. And then you put 5, and you always end up with 1. When you end with 1, it is finished. So 10 is 2 times 5. But these are so simple that I can do it in my head. 15 is 3 times 5. What is 18? 3 times 3 times
2.
2. Yes? And now if I ask you what is the least common multiple of 10, 15 and 18, if you can guess, just guess it. You don't need to write it down. If you cannot guess, this is the method. Yes? So I need to write all the numbers that I see in my list. The numbers that I see are 2.
90.
What?
Just...
No, I have 2, I have 3, I have 5. Yes? What is the highest power of 2? 1. Appears with 1, appears with 1, appears nothing here. So this is, the highest power is 1. What is the highest power of 3?
2.
2. What's the highest power of 5?
1.
1. And then you have to calculate that, so which becomes 90. Yes? 2 times 9 is 18. 18 times 5 is 90. So the number that we were supposed to guess is 90. In the book, you write 90 for this, 90 for this, 90 for this. This is really boring. So we just write this and we just put 190 here. And then you divide this 90 by that 10 in your head. How many times? 9. And you multiply that factor in the whole numerator. Into the whole numerator. And then next operation is addition. So I put plus and I repeat the process. 90 divided by 15 is how many times? Is
6.
6 times, yes?
Yes.
And then I multiply 6 by the numerator. But the next operation is subtraction. So put the subtraction here and repeat the process. 19 divided by 18 is 90 divided by 18 is 5, and then you multiply 5 into the numerator. And then you simplify. Simplification is just, so this is the only new lesson. That part, that's it. So what we do, we just simplify. 9x plus 27 plus 12x plus 6, and then I have minus 5x plus 10, yes? And then divided by 90. Okay, then let us add them. 21, 16x, and then this one and that one, 33, 43, yes? Okay, can I factor something out? No. End of the story here. That is the simplified version of those three fractions. Is that clear? Okay, but these are simple examples. You see, I intentionally gave you numbers in the denominator, but you can have algebraic expressions in the denominator, which would be more fun, but we will continue that next time. Yes, if you don't have any questions, we can end the lesson.
Yeah, we showed the gregarious prime.
Thank you.
We can, you can, prime numbers.